On this lesson, we're talking about Venn diagrams and subsets. First, we have a couple more terms to look at. First of all, the complement of a set. Okay, the complement of the set is all of the elements in the universal set, which is all of the possible elements under consideration, that are not in the indicated set. So in other words, it's all of the ones that are not in whatever we're describing. Okay, it's denoted with an apostrophe and read as prime. So for example, if we said that we're talking about set A, okay, so the complement of set A, I'll write it up here. So the complement of A is read as A prime. We put a little apostrophe on that, okay? So basically, the apostrophe means not, okay? So we have set A and we have not A, okay? So if we had all of the letters in the alphabet again, then if that was the universal set and set A is all of the vowels, then A prime would be all of the letters that are not vowels, okay? We have an example here. Let's say that U, so the universal set, is the set of n such that n is a whole number between 2 and 14. And remember, between means we don't include the endpoints, so we're looking at 3 through 13 here. And then set E is x such that x is an even number. And then B, set B is the set of the numbers 5, 8, 10, 11, and 12, okay? And we want to take this information and construct a Venn diagram so that we can then answer questions about it. So a Venn diagram, I briefly mentioned in an earlier video. A Venn diagram, and it's also defined down here, is a visual organization of the elements in related sets. So it shows bubbles or boxes, and the boxes show us how the sets relate to each other, okay? So we're going to make one of those. Here we have a universal set, and the box is going to represent the universal set, okay? So this is U. Everything that's inside this box is U, and I'll just put a little U in the corner there. And then within that, we have set E and we have set B, okay? And so I'm going to use bubbles for these, and they're going to be overlapping because there are some elements that are in both of those. Okay, so this is going to be set E, and this bubble will be set B. So what I'm looking at is how can I place all of the numbers in the universal set, so the numbers from 3 to 13, inside this chart, okay, inside this visual representation, so that I have the relationships between U and E and B correctly represented, okay? So the best way to do this is to start with the elements that are common to both, okay? So I know that E is an even number and B is the numbers 5, 8, 10, 11, and 12. So within the set of B, I see that 8, 10, and 12 are all going to be in set E as well. And therefore, I'm going to put those inside this overlapping piece between the two bubbles. So 8, 10, and 12 go inside that bubble. Okay? And then I can use either, it doesn't matter if I go to E or B next, but now I can use the original sets, E and B, to fill in the rest of those bubbles. B, I also am missing the 5 and the 11, so those are going to go over here in this part of the B bubble. Okay, because they are in set B, but they are not common to set E, so they go over on the outside part of that. And then also, what other numbers that are even numbers am I missing? I have 8, 10, and 12, but I need all the numbers from 3 to 13, so it looks like I need a 4, a 6, and then I have 8, 10, 12, and we don't include 14, so that's it, okay? So now I have all of the even numbers, 4, 6, 8, 10, 12, that are in between 2 and 14 inside my E bubble. And then I have all of the numbers in set B inside that bubble. I have the overlap between the two of those, 8, 10, and 12. Those are the values that are common to both. And then I still have a few values that aren't on here, though. So those are going to go into the universal box, but outside those bubbles, because they're not part of set E or B. And so I know that I'm missing a 3, okay, and then I have, there we go, 3, and then 4 is there, 5 is there, 6 is there. I'm missing a 7, and then I have 8, and then, so I'm missing 9, 10 is present, 11 is present, 12 is present, and I'm missing a 13. And it doesn't really matter where those go. Those just need to be inside the box but outside the bubbles, okay? So this is my Venn diagram that shows me how sets E and B interact with each other and with the universal set, okay, which is everything inside the box. So if I had questions about this, like for example, if I wanted to know what would be the set of E prime, okay, remember prime is complement, so that means all of the terms that are in the universal set but are not in set E, okay? So what I could do is I could, and sometimes shading is a little bit easier. This isn't a very tough one, but sometimes shading makes things easier. I could look at everything, I'm going to shade everything inside the box that is not a part of E, the E bubble, okay, which gives me this, all right? And then everything that's inside my shaded region is part of E prime, okay, is part of E prime. So I'm not using 4, 6, 8, 10, and 12, but everything else I do include in the set of E prime. So that's going to be 3, 5, 7, 9, 11, and 13, okay? Now, we knew that E was the even numbers between 2 and 14, and so E prime then would have to be all of the odd numbers. So it really is not necessary to make a Venn diagram for this purpose, but if we had, if we had 4 different sets that were interacting with each other and, 50 or 100 or even more different values to keep track of, then drawing it visually and using some shading can help us better identify what sets we're looking for, okay? And we'll do some more with that as we move on. Okay, so here is another example of a Venn diagram. Here we have a class of 20 students total. So this right here is telling me what my universal is. My universal set is the set of 20 students, okay? I know that 8 of them wear glasses, 12 have short hair, and 5 have short hair and wear glasses. And I want to draw a Venn diagram to represent this information. Now here it doesn't give me a list of students. So this Venn diagram is very similar to the previous one, but it's going to be slightly different in that instead of placing the elements, like a list of the students' names inside the bubbles, I'm going to need to use, need to just use the numbers of those sets. And if you remember, the number of sets is considered the cardinality, and let's hope this doesn't screw things up. I need to, oh, yep, that's what I thought would happen. Okay, sorry about that. Let's see if I can straighten this back out. We've got a little bit of a technology glitch here. Okay, better. All right, so we're drawing a Venn diagram for our class of 20 students. And again, we have a universal set of the 20 students. So this is our universal set. And then the 2 sets that we're considering are whether or not the students wear glasses or have short hair. So one of my bubbles I'm going to label as G for glasses, and one of my bubbles I'm going to label as S for short hair. And you can use whatever letters you'd like. It is important that you label them though, so you can tell what you're looking at when you look back at it. All right, so then how many students wear glasses? Well, 8 of them wear glasses, but I'm not going to put an 8 right here, okay? I'm not going to put an 8 right there because of those 8 students, some of them have short hair as well, okay? Have short hair as well. And same thing over on the other side. I'm not going to put a 12 over here because I don't know how many of those are in that outer bubble and not outer part of the bubble and not in the overlap. So I'm going to look at the overlap first. And I know that 5 have short hair and wear glasses. So that tells me that my overlap, there are 5 students that are common to both the glasses bubble and the short hair bubble, okay? And then I can use that then to fill out the rest of this. I know that 8 wear glasses. If 5 of them are inside this overlap piece, then that means there are 3 more on the outside. And then if 12 total have short hair and 5 are in the overlap, then that means I have 7 more on the outside, okay? And lastly, I need to figure out how many are in my universal set, but are not in the bubbles, okay? And since I have 20 total, I need to count up. I've got 3, 5, 7 I have 15 total students represented currently out of 20. That means I need 5 more out here in the universal box that are not inside those bubbles, okay? So another example, something we might need to do with this is we might need to do something like shade the areas of all of the students that do not have glasses, okay? So if we were asked to do something like that, okay, shading the regions that represent students that do not have glasses, then that's going to, or G prime, in other words, that's going to be all of this. Out here. Oh, I kind of went outside my bubble a little bit. That's okay. Okay? So you might have shading questions, you might have questions about numbers, but there's a lot of different things we can do with the visual representation. Okay. Next, some more terminology. Okay? Subsets. Set A is a subset of set B if every element of A is an element of B. Okay? So everything that is in A is also in B. And if that is true, then we say A is a subset of B. So this symbol right here means is a subset. And if you see it's a little different from this one down here because it has an extra line under there. Think about it like a less than or equal to sign or greater than or equal to sign. You know how we have that extra bar, the extra horizontal segment with the rest of the symbol that means it could also be equal to? Same kind of thing here. So this means it is a subset. It is possible, okay? It is possible that A equals B. It is possible that those are the same subset, or that those are the same sets. We don't know for sure whether or not they are just based on looking at A being a subset of B, but it is possible that they are equal. And I'm highlighting that because a proper subset, our next term, okay, means that every element of A is in B, however, they are not equal. So here, if you notice, it is missing the bar underneath saying that it could possibly be equal. So here they cannot be equal, okay? So A must have fewer elements than B. Okay? All of the elements in A have to be a part of B, but they cannot be exactly the same to be a proper subset. Okay? So here we're going to look at an example. Set K is the set of letters A, B, and C, and we want to list all of the possible subsets. Okay? And then we'll indicate which of them are proper subsets. All right, so first of all, our subsets could have any number of combinations or number of terms that come from the elements A, B, C, okay? So I'm going to list them systematically, starting with the ones that contain a single element, and then 2 elements, and then 3 that direction. So I'm going to start with A, okay, the set that just contains A, B, and C, okay? So far, all of these are proper subsets. I'll label it here in a second. Okay, now I'm going to do the ones that have 2 elements, so that could be A and B. It could be the set of A and C, and it could be the set of B and C. Okay? Remember, I do not need to list the set of B then A because that's the same as the set of A then B. The order doesn't matter, so that's not distinguishable from AB. Okay? So all of these right now are proper subsets. Okay? And then I have one more subset, and that's the set of A, B, C, okay, which is exactly equal to K, and therefore it is not a proper subset, okay? So this one is not proper, okay? But the other ones are. However, there is one more that I have to include as a possible subset that I have not yet written, okay? And that is the empty set. And again, we can write it as an O with a slash through it, or we could just write the braces with nothing between them. I prefer this notation. sometimes because the braces are tricky to write, but also because then you don't start to write the braces and then maybe forget whether or not you were supposed to put something between them. So here I am saying for sure the empty set is also a subset, and that's the subset, or the empty set is a proper subset of all sets. Okay, except itself. So all of these are proper subsets.